Here we have a situation where we have a spaceship that's at rest in deep space. Deep space is another way of saying that it's far away from everything, so we don't have to worry about the influence of outside factors. In particular, in this case, gravity. Its thrusters provide a force of 12,000 kilonewtons. The spaceship fires its thrusters for 20 seconds, and then it coasts for 12 kilometers. How long does it take for the ship to coast this distance? So we know that it's initially at rest, and it's going to fire its thrusters, which are applying a force to itself through its thrust. If it's applying that force to itself, it must be accelerating in that situation. It's accelerating across a certain amount of time. Once it speeds up, it's then going to coast for 12 kilometers. Coasting, in this case, means that it's moving forward at a constant rate, but it's not speeding up or slowing down. I guess its thrusters are off, so it's not speeding itself up, and the fact that it's in deep space means that there's nothing around to slow it down. And we want to know how long it takes to cover this distance. So, if it's coasting, that tells us that its velocity should be constant. And if we want to know the time that it takes to move 12 kilometers while you're coasting, while your acceleration is equal to 0, we know that from the x component of our projectile motion, that in this situation, the distance traveled is the velocity times the time. Basically, d equals rt. Distance is rate times time. We know how far it's going. We want to find how long it takes to cover that distance, so we need to have the velocity that it has while it's coasting that distance. Well, the velocity that it has when it begins coasting has got to be the same velocity that it has when it's done accelerating, when it's done feeling the force of the thrust from the engines. And so that means that we can treat this constant force as giving us a constant acceleration for 20 seconds. And thus we can treat it like a kinematics problem. The final velocity of our acceleration is what we're interested in. We're told that this acceleration happens for 20 seconds. We don't know how far it's gone in that time, and we're not really given much information to that end. But we are told that it's initially at rest. And so if we want to find the final velocity of this acceleration, to see how fast it's going as it coasts, we need one more variable. We need the acceleration. And so we can find the acceleration from the force of the engines. So our force is mass times acceleration. So our acceleration is force divided by mass. The force is 12,000 kilonewtons, and so we're going to change that to a times 10 to the 3 so that we have 12,000 kilonewtons. We're going to divide by the mass, which is already in kilograms, which is what we want. And we get that our acceleration is 150 meters per second squared. That's the acceleration that a ship that size would achieve with engine thrust that we're given. Now, if we know 3 of our kinematic variables, we can find the 4th one. And we have that our final velocity at the end of this acceleration is 3,000 meters per second. If we now know the velocity and we're given the distance, then we can find the time that it takes to coast this distance. So 12 kilometers, again we're going to say 12 kilometers is equal to 3,000 meters per second times t seconds. And we find that t is equal to 4 seconds. So what we've done is we converted everything to our SI base units as we went. That way we could end up with our time in seconds at the end rather than having to do a conversion there.